All right, taking a look at number 3. So number 3 says Katy Perry's the first person to reach 50 million Twitter followers, and that number continues to grow by 12% each week. Write a function that represents the total number of Twitter followers y after a certain number of weeks t. Right. All right. So there's kind of a lot going on there. So let's kind of break this down. In the first two problems, what we did is that to answer the question, we made a table. And a table wasn't too bad if you look back at what we did here. We're counting by $50 a month. Well, that's not too bad. We can handle that. In this case, the numbers were started pretty small, 3, 6, 12, and then they started getting a little bit bigger. But in real life, when we talk about real life numbers, like we're talking about here, number 3, 50 million. I don't want to make a table for 50 million. That's just way too many, right? So we want kind of think of it of a more efficient way to come up with our answer. Well, so instead of counting by a table's one way you could do it, but instead of counting by a table, we actually have a formula that we can use to help us get to the answer a little bit more quickly. And so all that we have to do is that we have to figure out, first of all, is the situation that we're talking about, is it something that's increasing or is it something that's decreasing? So as I read the problem, the key word that jumps out to me right away is the fact that we're saying that it's growing. Right, the number her Twitter followers are growing. So if that's the case, then once we've determined that we're talking about something that's increasing, we have a formula that's going to help us through that. So, and basically what this is saying is that if you take where something starts, that's what the A represents. When we say the initial amount, we're saying the amount that it starts at. So I could say that, well, y equals 50 million. Because we're saying 50 million, that's the A, right? Because this is the initial amount or the starting amount. So I'd have 50 million. And then it says times. And then you wonder, well, why times? Well, think back to what we did with the first problem there, is that we were multiplying. In this case, we were doubling. We were multiplying by 2. So we were multiplying by the same number each time. Well, so what we can do is instead of multiplying by the same number each time, because that would be kind of a long way to do it, you figure out what you're multiplying by, and then you use an exponent to say how many times you're doing that multiplication. So, well, how is it changing? So it says that, well, it's 1 plus whatever the rate is, right? So in this case, we'd say 1 plus, and the rate that we're looking at here is 12%, right? So this would be our R. So R would equal 12%. Now, what we're doing is that we're going to put this into the calculator. So the thing is that with the calculator, we can't put numbers in as a percent, so we need to switch that over to a decimal. So if you remember, it's real easy to switch a percent to a decimal. You just move it over 2 places. So 12% is really the same thing as 0.12. And I think of money. So if you think of any percent as pennies out of a dollar, so for instance 12%, I think of 12 cents. Think of a price tag, right? 12 cents on a price tag would be 0.12. So if you think about money, I think that's a real easy way to help you think about what's happening with percents. And then it says to the x, and x is the number of time intervals. So sometimes you may see x. Another thing you may see is that because time, that's because that's what we're looking for here, or what we're going to be solving with, is t. So you may see it written one or two ways. You may see it written as the exponent being x, or you may see it t, because oftentimes with these types of problems, the exponent represents time. Now we could do a little, combining some like terms there, just to kind of clean this up a little bit. So if I wanted to clean that up, I would just add those two together. Again, maybe thinking about money. So if I had $1, right? If I had 1 plus 12 cents, well, that would be $1.12, right? And so this would be my final answer there, right? At least for part A, because then what I'm going to do is, then for part B, is I'm going to use the equation I came up with in part A than to figure it out. Before we move on, though, just so you make sure you're kind of thinking like, well, why is the 1 there? Why is it 1 plus 0.12? Why isn't it just 0.12? Well, because what we're trying to do is that, think of the 0.12, this is the new part, right? So this is what you're adding to it because it's growing, right? And then the 1 represents where you already are. So when we calculate this, we want to know where were we plus how has it changed to give us the new total. So this represents how is it changing. The 1 represents kind of where we were, right? So that's why you need those 2 numbers there. So now it says how many would she have in 8 weeks. So what we're saying is that our t is equal to 8. So this is simple enough. I just take the equation I just came up with in part A. Y equals 50 million. And we actually left off some zeros there for part A. Let's fix that real quick. So we should have, let's fix that. So that was 50 million times 1.12 to the t. So we got 50 million times 1.12, and then we're wanting to know how many would it be in 8 weeks. So that would be to the 8th power. From here, we're just going to put this into the calculator. So let's open up our calculator. And I'm just going to type it in like I see it. Just clear out that other stuff we had in there. So you got 50 million. Right? So we've got 3 more zeros there. Right? Make sure we got all of our zeros. So 50 million would be 7 zeros. 1, 2, 3, 4, 5, 6, 7. All right. Times 1.12. So we can open up some parentheses. And 1.12. Close off those parentheses. And then how we do an exponent on this calculator is you see the little, on the right side over here, the little roof looking thing. Well, so I kind of think of that as raising the roof. So let's raise the roof. And then we're raising it to the 8th power. And then so we get a number there. So we're going to get a pretty big number there. Let's see if we can try to figure out what's happening there. I'm going to do a little squiggly because we're going to round because we can't have 0.8 people. So we're going to do a little rounding here at the end. But let's just get the numbers copied down first, and then we'll figure out what we're working with here. So 1, 2, 3, 7, 9, 8, 1, 5, 8. And if I wanted to round here, since this is, if I want to round to a whole number, I look at the decimal there. It's more than 5, so I'm going to round that up to a 9. So we'll say 159. And then, we put commas every 3 places, so that would be a comma. 3 more would be a comma. Right? And then, so what we end up with there is that 123 million Twitter followers. And that number might, again, this is just an estimate we're doing with the problem here. That's a pretty big jump. And she's over doubling her numbers in 8 weeks' time. Maybe 8 months, maybe that might be more realistic, but we'll just go with it as it is. Right? All right, so go ahead and stop now and try number 3 on the right side.